Okay, in this section 5, we'll be learning how a producer would maximize the profit in short run. So for decision problem, there are two approaches to look at the firm's production decision. One approach is to consider the profit maximization problem all in one go, or you can break the production decision into two steps. First, find the minimal cost of producing different level of output. And then next, using the production cost information to find the optimal level of output. And for this lecture, we will be looking at the first approach first, and in the next lecture, we will be looking at the second approach. So we will be just doing the profit maximization problem all in one go. So the assumption, we assume that firm is the price taker in each input and output market. That means the quantity that the firm produce, or the quantity of the output that the firm produce, or the quantity of the inputs that the firm demands into the production function will not affect the price of the input nor the price of the output, right? So output price is fixed, equal to P. W is the wage rate, or price of labor, also fixed. It is the input price, and R is also another input price for the capital rental price, which is fixed as well. Short run and long run, I think you are probably very familiar with the short run and long run. So I'm just gonna go over it quickly again. Short run is a period of time in which the quantity of at least one input is fixed. As a convention, we usually call the fixed output capital and the variable output labor. The long run is a period of time in which the quantities of all the inputs are variable. So we do not have a specified time duration in which it would be called short run or long run. So as long as at least one of the input is fixed in that time duration, then that time is called short run. If there is no fixed input at all, then that is the long run situation. That's it. Again, short run and long run are defined by the variability of inputs, whether or not any of the inputs is fixed or not. If none of the inputs is fixed, then it has to be long run. If at least one of the inputs is fixed, then it has to be short run. It's not about the length of time. So we start with a short run. Let's say that since we have a very basic production function consisting only two variables, right? Two input variables, L and K. So in the short run, one of these has to be fixed, right? So let's say we assume K to be fixed. So K cannot be changed. Therefore, the profit function, we want to maximize the profit. So we have to set up the profit maximization problem, where we want to find the maximum value of profit, where profit is total revenue minus total cost, right? Total revenue is P times Q. This is our P times Q. You can see that K here is fixed. P times Q less the total cost. Cost is the bill times L plus R times K. So that is the cost of the production, right? Or expenditure that the firm has spent to produce Q units. And the firm needs to find the optimal input L that maximize this profit function, right? Given that K is fixed, so you treat K as a constant. And another thing to look at this is called the variable cost, and this is called fixed cost, right? Because it is the fixed input, so this is going to be the total fixed cost. L is the variable input, so that is the total variable cost. Since there is a fixed cost, to be more careful, you may wish to also add a condition that if the maximized profit is negative, the firm will shut down, because it is possible that your profit function is actually be negative. Like let's say that it could be something like maybe your profit curve is possible, because in the short run you might want your profit. Let's say this is L, this is your profit, right? You want to find, the idea is you want to find, let's say L, so this is your profit function, profit curve. You want to find L such that the profit is maximized. You want to find what is that L is. So if it's positive, then you say, okay, if the maximized profit is positive, then you know that L has to be the best one. But it is also possible that, right? It's also possible that your profit function may be something like this, where your profit is actually in a negative domain. I mean, not negative range, right? Your profit function is actually negative, less than 0. So in this case, if you try to find L that maximize the profit, okay, this is the L that profit is the maximum, but the profit is still 0. It's a negative, right? So in short run, it is maybe better to just shut down or produce 0 than operating it. But also there is another thing that you have to also be mindful that not all the negative profit in the short run need to be shutting down. It need to like be a certain condition in which you know that if it operates, it might bear it. Okay, it would be something like, instead of maximize profit, it could be like a loss minimizing function instead, right? So if you have negative profit no matter what, right, like this, then you have to think, okay, then what would be my best way to minimize my loss? Either I should operate because I'm gonna pay the loss anyway, because if I shut down, I still have to pay the loss equal to the fixed cost, right? This is the cost that you cannot avoid. So if I shut down, you still have to pay the loss. I will lose anyway. But if I operate, how much I lose, right? So if you operate, then let's say you operate here, then maybe your loss value, your loss profit here might be smaller than if you shut down. Maybe if you shut down, your loss is gonna be negative. RK would be here, but if you operate, your loss gonna be here. So to minimize the loss, maybe it's better to operate, even though it means loss. So it depends on how big the loss is if operate. So you compare it with the fixed cost. If your loss from operating is greater than fixed cost, then negative fixed cost, well, when the loss are, I would say the absolute value, so that you don't get confused. So if your loss, right, is greater than the fixed cost, so this is the loss is greater than fixed cost, the absolute value. If the loss is greater than fixed cost, then you choose shut down, Q star equal to 0, shut down. But if your loss is smaller than fixed cost, then you actually should operate, produce something. Just some little details that you just have to be a bit careful about. Okay, so we are maximizing this profit function, and to do that we can obtain the first order condition, which is derivative of this profit function with respect to our choice variable L, and set it equal to 0. So this one we get P times MPL is equal, less the bill must be equal to 0, right? And then I give you the specific form of the production function F and the value of P, K bar, and the bill that you can solve for the profit maximizing L for the FOC. So you only have one equation with one unknown variable L, and it is solvable. No problem with that. So, and we can also rearrange this first order condition, and then we get, right, P times MPL is equal to the wage rate. The left hand side is the value of the marginal product. So this is MPL. This one is MPL. MPL times P. Remember what MPL means in the marginal product to labor. So when you increase 1 unit of labor, how much an extra output that would be created by that unit of labor, right? So that extra units of output produced by this unit of labor, you multiply by P, because you can sell that in the marketplace. You can sell those extra units of Q in the marketplace. You obtain the value, right, times P. So that is the value of the marginal product. This is the left-hand side, P times MPL. And the right-hand side is the wage, or the increase in the cost due to 1 unit increase in L. So you can think of this any way to, there are many ways to interpret this relationship. Another way to think about it is think of it as a marginal benefit versus the marginal cost, right? So I have L, let's say L is equal to 1, right? I was thinking as a producer, should I employ this first unit of labor? Then what I do is I compare the marginal benefit of the first unit of labor versus the marginal cost of the first unit of labor. As long as my marginal benefit is greater than marginal cost, then I would hire this unit of labor, right? How do I know marginal cost of that unit of labor? Yes, I know I have to pay the wage rate for that unit of labor. That is my marginal cost, right? What is the marginal benefit of employing this unit of labor? Well, I need to know that this person, how much he can produce. That is marginal product of the first unit of labor, right? So if he can produce 5 units of output, then my marginal benefit to hire him is that he can produce 5 units of output, and each unit of output can be sold for $2. Therefore, my marginal benefit would be 2 times 5, right? That is my marginal benefit. So this left-hand side is also the marginal benefit of that particular unit of labor. Then I keep going and say, okay, as long as my marginal benefit is greater than marginal cost, I would hire this guy. What about if the second unit of labor? I do the same thing, right? My marginal cost stay the same because I pay the fixed wage rate, but my marginal benefit might change. The reason it changed is not because P changes. P is not changed, right? P is fixed. That is the output price, right? P, W, and K bar is fixed. But MPL, we know that MPL would possibly change. It is possible to change because when L increases, so depending on how much exhaustion that has been gone, because we know that K is fixed. When you keep increasing L, right? You know that the marginal, because of a lot of diminishing marginal returns. Remember, when K is fixed, when K is fixed and one input is fixed, and you keep adding the other input more and more, then the marginal product to that unit of labor will become less and less. So that would result into the lower marginal benefit as more and more L employed. So eventually you will stop, right? So your marginal benefit, you know that marginal cost is fixed. It is fixed because it's equal to wage. But your marginal benefit would be falling because of law of diminishing marginal returns, right? Marginal benefit would be falling. So as you keep adding more and more levels, so they would think about, okay, how many L's that I would want to employ in order to maximize my profit. I compare between marginal benefit and marginal cost of each unit of labor. I will keep hiring, right? Keep going as long as marginal benefit is greater than marginal cost. And once they are equal, I stop, right? Once they are equal, I stop. And that would be my L star, the amount of labor units that would maximize my profit, which satisfy this equation. or marginal benefit equal to the marginal cost. At the profit maximizing choice of L, the two should be equal. And I just already explained in many ways why it is. Next, it's also always a good practice to check the second order condition, because for the maximization problem, we want to make sure that we have a, that's kind of the shape of the profit function that reach that what we found here is actually the maximum point, not the minimum point, right? We want to check that. So what we want to check that, okay, our profit function is actually have a decreasing in the slope, decreasing rate of the slope, right? So that the slope is go like kind of become, so if it starts from positive, it becomes negative and so on, right? So that it has that maximum point, and that's what we want. We want the second order condition to be negative, or the change of the slope of the profit function has to be negative. So if we remember, the first order condition is P times MPL equal to W, less W equal to 0, right? SOC is derivative, now derivative of the second order derivative of this function with respect to L. So that would give us PFLL has to be negative. And we know that this is automatically satisfied, right? Because this one is negative due to the diminishing marginal returns. If we have diminishing marginal returns, we automatically have this SOC condition, because this price is always positive price. So for this to be negative, this one has to be negative, which is equivalent of saying FLL is negative and FKK also negative, right? That's a diminishing marginal return. The short run unconditional labor demand. So revisit the FOC condition. This gives the relationship between the profit maximizing choice of L as a function of W. This is also known as the short run unconditional labor demand, right? So if you solve this equation, you will have L, you will get L star as a function of P, W, and K upper bar, right? You will get something like this, okay? So, and this is called the unconditional labor demands, because it asks, okay, how much labor inputs that a firm wants to demand, right? Given the wage rate, that is the demand, labor demand, right? The relationship between the price of the labor, in this case, which is the wage, and the quantity of labor demanded. So if you solve this equation, you will get L as a function of PWK. So we look at the relationship between the labor demand and the price of the demand or the wage rate. That is the unconditional labor demand in the short run. We say unconditional because we have not specified the particular output level, right? The analogy of this in consumer theory would be the Marshallian demand, which is obtained without specifying a particular utility level. So this unconditional labor demand is downward sloping. Suppose that the bill increases. So we know we saw this equation. So when the bill increases, right? If the bill increases, to maintain the equality, this left-hand side has to also increase, right? But since price is fixed, right? The output price is fixed. So we need to have MPL to increase. For MPL to increase by the law of diminishing marginal return, for MPL to increase, L have to fall, right? L falls, MPL would increase. You have to decrease L so that more marginal product to labor would increase. So you can see that there would be a downward sloping or the inverse relationship between the wage and the labor, right? And the labor demand. So when the wage increases, we see that the labor demand will fall. And this is the explanation. And therefore, L falls and W increases, the unconditional labor demand must be downward sloping. Right? Inverse relationship between the wage or the price of labor and the labor demand. There is no given factor. We will revisit this issue later when we talk about the long run production.